This video is on esters. Esters form when you add a carboxylic acid to an alcohol with a sulfuric acid catalyst. These form an ester. Here is a carboxylic acid. This one is ethanoic acid. F tells you there's 2 carbons. Oic acid tells you it's got a double bond oxygen to one of the carbons along with an OH group. This alcohol is methanol. Meth tells you it's got 1 carbon, and the OL, the methanol, tells you it's got an OH group. These combine together to form the ester methyl ethanoate. You can see the acid part in green and the alcohol part in blue. We name esters with the alcohol part first, so it becomes methyl, and then the carboxylic acid part second, ethanoate. So the full name is methyl ethanoate. Uses of esters include perfumes, flavourings and aromas. This is due to esters having nice, sweet and fruity smells. Esters can also be turned into polyesters, and polyesters can be used to make plastic bottles, clothing. Recycled polyesters can be used to make fleeces. When you react an ester with an alkali, like sodium hydroxide, you get soap. Fats and oils are just natural esters. They break down into glycerol and long-chain carboxylic acids. You should remember that acid plus alkali goes to salt and water. So when you have this long-chain carboxylic acid with an alkali, you form a salt. So soaps are just potassium or sodium salts made from esters and alkalis. Soap is dissolved in water. It forms anions at its head. The head is then hydrophilic. This means it's attracted to water, as it has a negative head. The tail, the long hydrocarbon tail, is hydrophobic. This means it doesn't want to mix with water. The way soap works is like this. Down here we can see the fabric, so this is your clothes. This grey dot here is meant to represent some oil attached to your clothes. Now normally when you add water, because the water will not mix with the oil will not be removed. However, when you add soap, the soap molecules surround the oil and lift it off the fabric. These diagrams down here are meant to represent a load of soap molecules all attached together. If you notice how the hydrophobic tails are all pointing inwards because they don't like to mix with the water which is surrounding here in the wash, whereas the hydrophilic heads are on the outside because they are attracted to the surrounding water. Unsaturated oils are esters with carbon-carbon double bonds. You can turn these oils into saturated fats by adding hydrogen across the bonds. So saturated fats are those with no double bonds. The same as alkanes have no double bonds and alkenes have double bonds. So you're going from an unsaturated oil, which is often a liquid, to a saturated fat, which is often a solid, and you're adding hydrogen. The equation for this is shown below. Here, this is just a small section of the unsaturated oil. It carries on for many, many more carbons. We're adding hydrogen gas. You can see the double bond here. What happens is the double bond breaks and the hydrogen attaches to each carbon which was part of the double bond before. This reaction requires a high temperature and pressure and a nickel catalyst to get the best yield in the quickest possible time. At the high temperature this reaction is carried out, the fat actually exists as a liquid, whereas the nickel is a solid, so the nickel can simply be filtered out. Then as it cools down, this will turn into a solid fat.